Hey everybody, welcome to section 16-2. Today we're going to classify triangles, which means what we're going to do is look at a triangle and give it its name. So in class we talked about how many families have the same last name. My family, for example, our last name is Melia. However, my first name and my middle name are different from my mom's first name and middle name. They're different from my dad's first name and middle name and my brother's first name and middle name. They're also different from my wife's first name and middle name and my daughter's first name. But we're all part of the Melia family. That's how triangles work too. Triangles are all part of the family of triangles, but we talk about their first names and their middle names a little bit differently based on what they look like. So the first name of a triangle talks about its sides. And you can have three things. You can have an equilateral triangle, where all sides of the triangle are equal lengths. You can have an isosceles triangle, where two sides are equal length. Or you can have what we call a scalene triangle, where zero sides are the same length. You're going to use one of these three names for the first name of the triangle. Name 1, name 2, or name 3. The middle name of the triangle comes from the angles that make up that triangle. By definition, a triangle has three angles. Tri meaning three and angle. You have an acute angle where all of the angles in the triangle are less than 90 degrees. A right triangle where one of the angles forms a 90-degree angle. Or an obtuse triangle where one of the angles is greater than 90 degrees. And then, as I mentioned, the last name of the triangles always stay the same. So I have three examples here that we'll talk about and we'll give names to. The first one, I'm going to classify this triangle by its sides. Well, I can see that none of the sides are the same. So, looking at which one of my names has zero sides of equal length, it's going to be a scalene triangle. The scalene. Now, I need to look at the angles. Well, this angle here is an acute angle. This angle here is an acute angle. However, this angle right here is an obtuse angle. This angle is greater than 90 degrees. So I found an angle that is greater than 90. I only need to find one to make it an obtuse triangle. So we have a scalene, obtuse triangle. In my second example, I'm going to look at the sides first. Now these little dash marks tell me that these sides are all equal. I have three equal sides. So on my sides list, I'm going to look for the name that has all sides being equal. So this is an equilateral triangle. I'm then going to look at all the angles. Well, I see that this is less than 90 degrees, an acute angle. This is an acute angle here, and this too is an acute angle. So what I have here is an equilateral, acute triangle. And then finally, I have my last example. I see that this side and this side are equal because the dash marks are telling me so. So I have a triangle that has two equal sides. That would be an isosceles triangle. An isosceles. Now what angle? Well, here's an acute angle. Here's an acute angle, but right here, I see a square in the corner telling me I have a 90-degree angle. That forms a right angle. So I have an isosceles right triangle. Classifying triangles isn't too difficult. You need to just take it step by step. Do the first name first, the sides of the triangle. It's either an equilateral, an isosceles, or a scalene triangle. Then take it as a second part of the problem, looking at the angles. You either have an acute for all three angles, a right where one of the angles will form a 90-degree angle, or an obtuse triangle where one of the angles is greater than 90 degrees. Remember, for these two, for the right angle and the obtuse angle, only one of the angles needs to hit that mark, not all three. By definition, it cannot happen for all three. Okay? So keep that in mind, study your charts, and thanks for watching.